Hey guys, we're going to do another chapter 5 video here. Topic is 5.4, and we're going to talk about actually a few different things today, but essential question is, what is rate of change? And so we're kind of nearing the end, well, or the middle, I guess, of our unit that we're in currently. And rate of change is something that is going to start as a skill we learn in algebra, but it kind of builds as you move up through higher level math classes. In fact, it's a huge deal when you get up to those like calculus classes. And so here's the basics of it. In our notes, we're going to write down 3 situations. The first one is this. Dan drives his car 30 miles per hour down Miller Street. Okay, so if I go fast, pause the video and go ahead and write these down. Dan drives his car 30 miles per hour down Miller Street. Here's the next situation. Dylan reads her book at a rate of 14 pages every 5 minutes. Dylan reads her book at a rate of. Those are some key words. 14 pages per every 5 minutes. Sarah delivers newspapers at a rate of 24 papers every 20 minutes. So all 3 of these situations are different. Dan's driving his car 30 miles per hour. Dylan's reading her book at a rate of 14 pages every 5 minutes. And Sarah's delivering newspapers at a rate of 24 papers every 20 minutes. And what do all 3 of these have in common? Well, they all have a speed. How fast is Dan driving his car? How fast is Dylan reading her book? How fast is Sarah delivering her newspapers? And in algebra and calculus and in math in general, we call that rate of change. Speed is a rate. So rate and speed kind of mean the same thing to us. Another word that I tied to this is slope. If I was to graph these situations, the speed or the rate is actually the slope of the line. It's remember, delta y, delta x, change in y, change in x, it's the rate of change. So speed, rate, slope, all mean the same thing. They're all words for the same thing, which is kind of cool and also kind of confusing to a lot of people. So we're going to do a rate of change problem today, and you're going to need a lot of space in your notebook. Plan to do some big graphing and kind of use up a lot of room for this. And our story today is called The Race. So you're going to title it The Race. And there's a cool picture of a tricycle down in the corner because the race is a tricycle race. And here is the story. Evie and Joyla are competing in their local tricycle race. Do you remember Evie and Joyla from earlier this year when we were studying the dog sled race problem? They're back at it. They're going to race tricycles. And to prepare, they are training and racing each other to practice and get ready. Evie began the race at the starting line and rode at a constant rate of 2 meters every second. Rate, that's her speed. Joyla rode 5 meters every 4 seconds and got a 6-meter head start. All right, so what we're going to do is we're going to answer this question. We're going to answer, will Evie catch up and pass Joyla? Joyla got the head start. You ever race with like a little brother or sister? Sometimes you're nice, sometimes you're not, but you might give someone a head start. Well, Joyla got the head start. And the question is will Evie catch up and pass her? So we are going to answer this question very thoroughly today. We're going to take the algebra approach to answering it. And my first thought is let's get out of this story the facts. So in our notebook, we're going to say facts. And the first fact I'm looking at is Evie began the race at the starting line. That sounds like a key note that I should write down. So Evie, which I'm going to put in red just to color code everything. If you want to color code your notes, you might do one color for Evie, one color for Joyla, perhaps. Evie's going to be red for me. She started the race at the starting line. So that's my bullet point, starts at the starting line. That seems pretty important. The other important piece is she rode at a constant rate of 2 meters every second. That's her speed, 2 meters every second. I'm going to write that down as an important fact. Okay. Well, if she can go 2 meters every second, that means the change in meters over the change in seconds is 2 over 1. Notice I'm using the delta symbol. That delta symbol means change. So her change in meters over her change in seconds is 2 over 1. Okay, so that's Evie. Now let's talk Joyla. Joyla rode 5 meters every 4 seconds. So Joyla's going to be in blue, kind of like teal blue for me. And her speed is 5 meters every 4 seconds. And she got a 6-meter head start. That was the other clue that sounded important. So I'm going to write that down as a bullet point. 6-meter head start. Okay, well, Joyla's speed, her change in meters over change in seconds, is going to be 5/4. She goes 5 meters every 4 seconds. That's her rate. So these are the facts from the story. We're going to take these facts and we're going to graph them first. Okay, so we're going to graph this thing, and we know there's not going to be any negative numbers because it's a tricycle race. Why would there be negative time or negative meters? It wouldn't make a lot of sense. So I'm going to make a big first quadrant graph. I'm going to use my ruler and draw a nice big XY axis, so you're going to do the same thing. And then we've got two different variables to kind of be thinking about. They're tricycling, and they're going in meters per second. So time, seconds, is going to go on the x-axis, and meters, which is our distance in the race, is going to go on the y-axis. Be sure you get those labels on there, time and distance, seconds and meters. So that'll be our x and y axis, and then we'll take our pencil and we'll put some scale notches on here so it looks a little more clear. Okay, so now we got to do a little bit of work. We got to get all the numbers on here. So I'm going to keep it simple. I'm just going to go by ones. I'm going to make it big though. I went out to 15 seconds at least on the race at a minimum, and we might have to go farther potentially, so I have a little extra room. So 1, 2, 3, 4, 5, and the same thing going up the y-axis, I went to 20 meters. 1, 2, 3, 4, 5, all the way up to 20. So this might be where you need to pause the video and like set up a nice looking graph. But once your graph is ready to go, we're going to graph Evie and we're going to graph Joyla. And I'm going to use my colors. Remember, Evie was red and I used like a teal blue for Joyla. I'm going to stick with that as my plan. So looking back at the facts, Evie starts at the starting line. So let's think about that on our graph. So she's on her tricycle. She's at the starting line. On your marks, get set, go. Boom, the gun goes off. Everyone starts racing. When that clock, when they say on your marks, get set, go, that's when they click the timer on the clock, and that's when it begins. So what time is on that stopwatch when the whole race begins? 0 seconds. The race hasn't started. On your marks, get set, go. Click. Okay, the stopwatch starts counting its seconds. So at 0 seconds, when she's at time 0, what's her distance in meters if she's at the starting line? Yeah, 0 meters. She hasn't traveled and the time hasn't started. She's at 0, 0. And that's where we're going to put Evie's first point is 0, 0. Because she's gone for 0 seconds and she's traveled 0 meters. But then how fast does she go? What's her rate of speed? Remember that? She goes 2 meters every 1 second. So what we're going to do is we're going to notice that her speed is 2/1 and we've got her point at 0, 0. So we're going to take that point and we're going to move it up 2 meters over 1 second. Then we're going to repeat that, up 2 meters over 1 second. This is her slope. She goes 2 meters every 1 second. And I'm going to do that for quite a ways on this graph. I'm going to go up 2 meters over 1 second. And kind of just keep repeating that because I'm going to want lots of solid points. So up 2 meters over 1 second. Up 2 meters over 1 second. And I'm just kind of repeating that over and over now. Up 2 meters over a second. I'm going to go to the very top of this graph. Up 2 meters over a second. Up 2 meters over a second. And kind of just keep repeating this pattern until I run out of space, basically. So I have all these plotted points. And what I'm going to do is grab a ruler and connect them. I'm going to use red because that's my color for Evie. And at the top where I drew my arrow, I'm going to label it Evie so I don't forget. So that's Evie's line that represents her tricycle race. But now we got to put Joyla on there. So where was Joyla standing when the time said 0 on the stopwatch? On your marks, get set, go, click, the stopwatch starts, time 0. Where was she standing? Well, Joyla got the head start. So she's not at 0 meters. She got a 6 meter head start. So when she starts the race, she's already at a distance of 6. She's already got kind of a lead on that. So we're going to start her at 6 on the y-axis, 6 meters. And then, what was her speed? She can go, you guys have your notes in front of you, probably a little easier to look at than me, but she can go 5 meters every 4 seconds, I believe. We're going to take that point and we're going to go up 5 meters over 4 seconds and place the next dot. That's her speed. We're going to go up 5 meters over 4 seconds. Ah, there's the point of intercept. Up 5 meters over 4 seconds. This is going to create her line. Up 5 meters over 4 seconds. I'm off the graph now. So since I'm using kind of a greenish blue here, I'm going to connect her just like that, and I'm going to label it Joyla. And then now I'm ready to begin answering our question. We have a point of intersect. It's happening right here. So let's see. If I go down, looks like it hits at 8, and it looks like 16. I hope your graph matches mine, which means our point of intersection is at 8, 16, and I'm going to label that on the graph. Sweet. Okay, so we have a nice looking system here. We've got 2 lines, we've got a point of intersect, we've labeled it. Everything's looking pretty good. But I'm going to kind of zoom out on this and take this to the next level. If I'm doing this on like a test or something, I want to be that level 4 advanced. I really want to prove my answer. So I'm going to go farther with this. And my next step is I'm going to define my variables and write some equations. So there's 2 variables going on here. In this case, we have an x and a y axis, so our variables are x and y. And we're going to define x first, let x equal something. Well, if I look at my graph, x looks like it's the time in seconds for this race. So let x equal time in seconds. Then I'm going to define my y variable. Well, if I look at my graph, y looks like the distance in meters. So let y equal the distance in meters. There's my 2 variables. Now I'm going to write some equations. Well, there's going to be 2 equations, one for Evie, one for Joyla. And they both are linear lines. So think y equals mx plus b. Let's start with Evie first. Her speed, her rate was 2 over 1. It went up 2 meters over 1 second. So she has a 2 over 1 slope. So m is 2 over 1, x, plus what's her b? Where did her line start? Well, Evie started at 0. She had no head start. So to kind of clean up this equation, 2 divided by 1 is just 2. So it's kind of like y equals 2x. And I don't even need the plus 0. That's added information, but it doesn't really need to be written there. So that's Evie's equation, y equals 2x. Now let's do Joyla. Well, Joyla had a slope of 5/4, 5 meters every 4 seconds. So her line is going to be 5 over 4x. Plus, where did she start? What was her y-intercept? She started with the 6 meter head start, so plus 6. So her equation is y equals 5/4 x plus 6, and that's Joyla. And I can't really clean that one up very much. There's no simplifying to be done there. So we've got 2 equations for our lines. We've got defined variables. We've got the facts in the graph. We've got a lot going on here. What's next? Well, the next part is we solve these equations. We pick a strategy: elimination, substitution, or equal values. Those are our 3 possible strategies we could use. And looking at these equations, they're both in y equals. So I'm thinking, let's use the equal values method. Let's set 2x equal to 5/4 x plus 6. Put a line down the middle. We're going to solve for x. With that fraction, I really don't like that fraction. So I want to get rid of it right away. That's my plan. So to get rid of the 5/4, I'm going to multiply everything by 4. In doing so, it's going to kind of kill the fraction, make it go away, and then make this a little bit easier. 4 times 2x, I've got to multiply 4 by everything. So 4 times 2x is 8x. And then when I multiply the fraction, the nice thing is the 4's cancel out, and I just have what's left is a 5 and an x, so 5x. Plus 4 times 6 is 24. Now this is so much easier to solve. Once I get rid of that fraction, it's easy from there. So I'm going to take the 5x away. 8x, take away 5x is going to be 3x, and it's equal to 24. And then I'll get rid of the 3 by dividing by 3, and 24 divided by 3 is 8. So x is equal to 8. There's our answer. But don't forget, we got to solve for the other variable. So now I got to go over to the side here and solve for y. Well, I'm thinking when I go back and look at my equations, which 2 equations do I want to use? Do I want to use Evie's or Joyla's? They both would work. Joyla's has a fraction. I'm going to avoid that one. Let's use Evie's. Y equals 2x. Well, we think x is 8. So we're going to do y equals 2 times 8, and 2 times 8 is 16. So there's our second answer. So we have 8 and we have 16. I'm going to write it as a coordinate point, 8, 16, put a box around it, and that's my final solution. Well, of course it's 8 and 16, because remember, back up here, isn't that exactly the point of intersect we got on our graph? So our work is matching up, and now we're double verifying. We're really proving that we know when these 2 racers cross paths on the race. It's at 8 seconds and 16 meters. So we've got some solid proof now. But I'm not done. I'm going to add another piece of proof in here. I'm going to use tables to prove my answer. I've got the graph. I've got the equations. Now I'm going to use tables. This could be the next step to really verify. So I'm going to make a big table, and I'm going to do one for Evie and one for Joyla. Let's see. We've got the variable x, which is in seconds, and we've got y, which is the meters. And if we start with Evie first, we know that at 0 seconds, she had a 0 meter head start. She had no head start, so that's where she began. But then remember her speed. She could go 2 meters, so if we add 2 meters on, every 1 second, we'll add a second on. So we're going to add 2 meters every 1 second. So if we count up by 2 for meters, that means she'd go 4 meters in 2 seconds, 6 meters in 3 seconds, and the pattern's going to continue 8 meters in 4 seconds, and so on. 10 meters in 5 seconds, 12 in 6 seconds, 14 in 7 seconds, and 16 in 8 seconds. So there's Evie's table. Now I'll make a matching table for Joyla. So same variables, x and y. X is seconds, y is meters. Again, if I'm going fast, just pause the video. I'm going to label it Joyla. And then where did she start at 0 seconds? Well, she had the head start. Joyla was actually 6 meters ahead, so she starts at 6 meters. But her speed was she could go 5 meters, so we're going to add 5, 6 plus 5. 5 meters would make it 11, every 4 seconds. So we're going to add on 4 seconds. So our pattern is we're going to add 5 meters every 4 seconds. So if I add 5, it'd be 16 meters. 4 seconds would make it 8 seconds. If I add 5, it'd be 21 meters. And that'd be 12 seconds. And I could continue my table, but I really don't need to. Why? Because look, my point of intersect. Here's how my tables prove that my answer is correct. They match at 8 and 16. So I'm going to add that to my big picture here. Check this out. We have now proven that our solution is Evie catches up and passes Joyla 8 seconds into the race. This is 16 meters from the starting line. 16 meters from the starting line. So we have a pretty solid piece of evidence here that says we know when Evie catches up and passes Joyla. Okay, so to wrap up our video, the idea with this video is I wanted to show you how to really take a systems problem to that advanced level 4 work. And it's kind of big picture here. So big picture is we can prove our answer with a graph. We can prove our answer with the algebraic method, in this case equal values, but sometimes it might be elimination or substitution. We can prove our answers with tables. And then, of course, it all kind of starts with the story. What's the story and what's the situation? It's those 4 representations: graph, the algebra equations, the tables, and the story. And we're trying to get all of those in there. So hopefully, if you get an opportunity to do a story problem soon, you'll practice doing this. Can you graph it? Can you do the algebra? Can you make the tables? Can you get all representations in there? So I hope this helps, guys, and thanks for watching. I'll see you in the next video.